up to a chapter review because our test is next session. We spent our time learning how to solve and work with inequalities. We start with our simple inequalities, which could be one-step, two-step, multi-step, or variables on both sides. We'll use the same procedure that we use to solve equations, using our inverse operations to isolate a variable. And then we'll see that we have 5 is greater than x. And as you recall, we need to always rewrite an inequality with the variable first. We get x is less than 5. The next step was to graph. And if we're going to get our graph together, we're going to start, and we recall this is an open circle, and we shade everything less than. So we now represented this inequality with the inequality statement with a graph, and let's now do our interval notation. Since it's going into negative infinity, we have the following. Let's see a second problem. This is a multi-step with variables on both sides. Let's collect our variables to one side. That leaves us with negative 4 is less than or equal to 4x plus 20. Start isolating your variable, again using your inverse operations. Lastly, divide. And you get negative 6 is less than or equal to x, which again we're going to rewrite as x is greater than or equal to negative 6. Now that we have that, we'll graph. We see this will be a closed circle and shading everything into positive infinity. Interval notation will look in the form of a closed brace here with negative 6 comma into positive infinity, and done. Covered a couple of topics there all in one, showing how they're all tied together. From there we looked at, is this number a possible solution? And the way we do that is by replacing the variable with the given number or value. We'll then do the math, and I get 20 minus 3 is greater than negative 17. Well, is this a true statement? Is 17 greater than negative 17? The answer is yes, so 4 is a solution. We're testing out a possible solution by replacing the variable with a given value. Negative 2 times 3 plus 3. We want to see that when we're done simplifying, if that statement is true. And once again, we see we have a true statement, so 3 is a solution. Testing out. From simple inequalities, we moved on to compound inequalities, and we found out there were 2 types. When our variable term is in the center between 2 inequalities, we know it's an AND. And what we'll do is whatever we do in the center to isolate the variable, we'll do on both the left and the right. We're now up to the part where we can graph, and we see that we have an endpoint at 7, an endpoint at 12. They're both open circles. And this can be read from the center, and it says that x minus 3 is greater than 4, and x minus 3 is less than 9. I'm sorry, 12. Oops, sorry, I switched that up. And then, well, that's the initial statement, I should say. And then when we go to get the solution, I can leave that there. The solution says that x is greater than 7 and x is less than 12. So if you wanted, you could break it up to this top part and solve, or keep it as 1. In an AND, in an OR, you'll see the word OR. You're going to use your inverse operations again. You'll get 3D is equal to -4, and you'll divide by 3. On the second part, we'll have subtract 2. Okay, so we have D is less than -4/3, or D is greater than or equal to 2. Number line, 0, 1, 2. So at 2, I'm going to have a closed circle and shading everything greater. ORs will go in opposite directions. This is -1, -2. It falls somewhere over here, open circle, and shade everything that's less than. So there you have our compound inequalities. When we were done with that, we went into interval notation just a little bit. We talked about that we can write this as an inequality and also as a graph. So think about how you would go about graphing this. If you have something at -1 and something at 10, this is telling me this is a closed circle. This is telling me it's an open circle, and it'll shade in between. In this next one, number line, at 4 I have an open circle, and it's going into positive infinity. So again, we can take this, we can convert them into graphs. We can actually write the inequality, and this would be a compound inequality. Think about how that would look, and we'll go over that in class. So you're going to write the inequality here. Second one, again, we've graphed it. Now what would be the inequality that matches that graph? Absolute value, we spent some time yesterday reviewing. We solved twice. And again, recalling that when there is something attached to that, we need to isolate the absolute value expression first. Try these two, and we'll review. We then went into our absolute value with inequalities, and we know that when it's a greater, we'll have the OR type. So we'll have the 3x minus 4 is less than -12, or we'll have 3x minus 4 is greater than 12. When we see a less than, that's when we'll set it up in the middle and solve. Once again, we'll check those in class. And one of the last things we talked about was our union and intersection sets as well as subsets. And that'll be the last thing we'll go over in class.